right, today we are going to look at solving two-step equations. So I have an equation here. We're going to try to isolate our variable. We're going to try to get that w by itself. So we have to move things away from the w. You want to start by removing anything that is being added or subtracted. So in this problem I see that we have a plus 10. So to move that to the other side, or to move that away from the w, I'm going to subtract 10 from both sides, keeping in mind that my equal sign is the balance of my equation. So when I do that, this plus 10 minus 10 cancels out. I'm going to bring down my 3w. That's going to equal 16 minus 10, which gives me 6. Now that I have removed what was being added or subtracted, now I have to look at what's being multiplied or divided. In this problem here, we have 3 times w. In order to undo multiplication, we use division. So I'm going to divide both sides by 3. 3 divided by 3 will make 1, and that will get rid of those, leaving me with just w. 6 divided by 3 is 2. So let's take a look at another example. All right, in this problem here, we have x divided by 2 minus 5 equals negative 4. And again, the object of the game is to get everything away from this variable x. So just as in our first example, we're going to start by looking at anything that's being added or subtracted. We have a minus 5, so we're going to get rid of that first. The opposite of minus 5 is plus 5. Again, keeping in mind that that equal sign is going to serve as the balance there. So minus 5 and plus 5 make 0, so it's gone. I bring down my x divided by 2, and that equals negative 4 plus 5. Well, negative 4 plus 5 is going to give me 1. Now, in my next step, again, I'm trying to get x by itself. X is being divided by 2, and the opposite of dividing by 2 would be multiplying by 2. So I'm going to take both sides and multiply it by 2. When I do that, this multiplying by 2 and dividing by 2 are going to cancel out and leave me with x. 1 times 2 is going to give me 2. All right, let's take a look at a third example. In my third example here, I have decimals, and it's perfectly fine to have decimals. We're going to work this problem the same way. So we're going to start by noting that we're trying to get y by itself, and we're going to move anything that's being added or subtracted. So since we have a minus 1, the opposite of minus 1 is plus 1. So I'm going to add 1 to both sides, again remembering that that equal sign is my balance. Minus 1 plus 1 is going to cancel out. So I'm left with y divided by 3 equals 2.21. So I added 1 and I ended up with 2.21. So now what I have to do is I have y being divided by 3. The opposite of dividing by 3 is multiplying by 3. So I'm going to multiply both sides by 3. When I do that, this multiplying by 3 and dividing by 3 cancel out. And I'm left with y equals, and then 2.21 times 3 is going to give me 6.63, or 6 63/100ths. All right, one more example to look at. Just like in our other examples, the object of the game is to get the variable by itself, so I've got to move everything away from m. Now this one's a little bit tricky because I have a negative 10 that's being added to 4m. So normally we'd say, oh, well, since it's being added, we should subtract. But actually this is a negative 10, and we're going to do the opposite of the symbol that's in front of that 10. So since it's a minus 10, I'm going to do plus 10. And I'm going to do that on both sides. Again, remembering that my equal is kind of my middle, my balance there. Minus 10 plus 10 makes 0, and it cancels out. I bring down my 4m, and that's going to equal, well, negative 2.8 plus 10 is going to give me 7.2, or 7 2/10. So in this next step, I have to divide both sides by 4. 4 is being multiplied by m, and to undo multiplication, we divide. So if I divide by 4 on both sides, I get m equals 1.8, or 1 8/10.